What's up, everybody, and welcome back to another video on SAT Math from the Scalar Learning channel. And once again, I'm going through one of these mini tests from Khan Academy. I do recommend them. Sometimes the questions get a little more difficult than the actual SAT Math, which is a bummer, but I do think overall it's a nice mixed bag and mixed review to get you ready for the SAT. By the way, before we begin, we've got our SAT Math courses finally out there. People have been asking me to create a new, better, and improved one than I did in the past, and this one is amazing. We've got 4 amazing bona fide time practice tests that you won't find anywhere else on the platform. And each practice test, every single question comes with a customized personal video explanation from me that's quick, to the point, but explains it clearly and effectively. We've also got all the critical concepts laid out for you. We've got amazing downloadable PDFs for the formulas that you can't find anywhere else as well. And last but not least, we have an amazing meditation video, guided meditation to help you calm yourself. It's something you can do on a daily basis. Without further ado, let's get into this calculator section. Here we go. Timed. Let me get my web paint in the mix. And we're going to start. And I got the calculator over here if I need it. 3, 2, 1. Let's go. During a time test, Alexander typed 742 words in 14 minutes. 742 in 14 minutes. Words, minutes. Assuming Alexander works at this rate for the next hour, we're telling best approximate the number of words he would type in that hour. So an hour is 60 minutes, and that's the unknown. Cross, cross. Let's use the calculator. 60 times 742 equals divided by 14, right? Because it'll be 14x equals that. So divided by 14, this is the winner. Boom, done. The graph at the left the graph at left in the RI plane shows the current I in amperes for a circuit with a resistor having R ohms of resistance. What is the significance of the value I equals 4 shown by the dotted line? Okay, let me think about it. It's an asymptote. Wait, hold on. Let me understand this for a second. So the current will never go below 4, I guess. The current for a resistor. No, it's not this. A minimum when the resistor has a resistance of, no. As the current becomes large, the resistance becomes, no. As the resistance becomes large, the current becomes approximately 4. Yeah. So it's basically like as the resistance increases, we get to 4 amperes. All right, D is the winner. Okay, next. A class test of the reaction times to catch a falling object. The dot plot above gives the results to the nearest tenth of a second. Which statement best compares the median and the mean? Got it. Okay. How many people? Let me see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. Look, here's the main thing. You got outliers, and I know the outlier impacts the mean. So the mean's obviously going to be higher than the median. The median's going to be, somewhere in here, and the mean will probably be out here. We don't need to calculate it. The mean's definitely greater than the median. Whatever. I mean, it's just, if it was symmetric, then we'd know they'd be equal. So it's definitely, I don't think we could calculate the mean right now. I'm not going to. It's going to take forever, but yeah. So the mean is going to be greater because of that skew. So A is the winner. All right. Numero 4. Anna's considering 3 insurance options for a business shown at the table. She wants the total cost C plus D to be at most $2,000. Wait, she also wants the benefit, which is 90% of 10C minus D. 90% of 10C minus D to be at least 12,400. Okay, so which of the following option selections would fit Anna's plan? Let me think about this for a second. So she wants C plus D to be at most 2,000. So this one is out. Option 3 is out because it adds to greater than 2,000. And then she wants 90% of this to be greater than 12,400. So let's see, 17,000, 10C is 17,000 minus deductible of 250. And then we need that times 0.9. She wants that to be greater than 12. Okay, so option 2 works. And then 1 is, oh God, okay. 10 times 1425 minus 450. And then times 0.9. They both work. Cool. Because that you see that's above the 12,400. So boom, done. To rent a car for 1 week, a car rental company charges $200 base price as well as 45 cents per mile. Jennifer will rent a vehicle at this company, but she has a $275 budget. Which of the following is a possible number of miles that Jennifer can drive without exceeding her budget? Okay. So it's 200 plus 0.45x has to be less than or equal to 275 as the budget. So we subtract 200, and we get 0.45x is less than or equal to 275. Divide by 0.45. Obviously, I'm going to use the calculator for this. 275 divided by what did I do? Oh, I didn't subtract. Sorry. That's supposed to be 75. My bad. All right, 75 divided by 0.45 is 166. So which of the following is a possible these questions, when I think back on it, it's like all they're saying is which is possible to drive without exceeding your budget. It has to be the smallest number. It's a poorly designed question because if this one works, then that one works too. So it doesn't say which is the following is the maximum number she can drive. Anyways. All right, 6. Rajiv has 175 that he earned from his summer job. He puts the money in an account that yields 4% compounded interest. So that's like times 1.04 annually. After how many years from the time he deposits money will he have at least 200 in the account? So it's like, when does this equal? You know what? I'm just going to plug and chug. Let me think. Okay, yeah, I'm just going to plug and chug. 175 times 1.04. Let's start with 4 years. I don't know. Okay, so 4 works. So and then 175 times 1.04. Whoops. 04 to the third power. That does not work. So 4 is the winner. Cool. Knowing that compounded interest formula is very helpful. Which expression is equivalent to this? Okay, again, you don't have to worry about those. That's just ensuring we don't divide by 0. 2mc squared. Hold on, I don't need the calculator for this. 2mc squared over 6b times 3b cubed over 10c to the fourth. And then let's see if we can cancel stuff out. So that cancels out with this. So c squared, and that becomes, that c to the fourth, 2 of them cancel out c squared. The b cancels out. This becomes a 2. Okay, so then I have 6mb squared on top over, actually, wait, the 6 and this cancel out. 10c squared on the bottom. So mb squared over 10c squared. B is the winner. Done. All right. 8. A small business model is weekly revenue, product number of units sold, and the price per unit by the quadratic equation, by the quadratic function, where x is the number of units sold. Okay, let me think about this for a second. Oh, what is the max? No problem. So I'm going to rewrite this as negative 0.1 x squared plus 50x. And the max is the vertex, and it occurs when x equals negative b, which is negative 50 over 2a. So that's negative 50 divided by negative 0.2, which is 50 divided by 0.2. I know it's 250, but let's just do it just to be safe. 250. So the max occurs at 250, but that's not the max. And then we plug it in here. And we say 50 times 250 minus 0.1 times, okay, 250, and it's got to be squared. Just making sure I didn't make any mistakes. 250 squared. And we get 6,250. So that's the max revenue, max of a quadratic. Cool. 9. The apparent brightness of a surface in lux is found by measuring the energy of the light coming from the source and dividing by the area of the surface. Okay, wait. Measuring the energy of the light coming in from the source and dividing by the area of the surface. Lux are equivalent to candles, to candelas per square meter. Square meter, I don't really know. Okay. Abigail's building a new type of television screen and measures the brightness of glare to be 0.0002 kilocandesas per square centimeter. Okay. Okay, so we got to convert back to candelas. Okay, got it. So 0.0002 kilocandelas over centimeters squared. And we need to get it back to square meters. So kilo, so to be regular candelas, 1, 2, 3. So it's 0.2 candelas per centimeter squared. And then I have to convert to square meters. Hold on. So I go, how many square meters, how many square centimeters in a square meter? And this gets a little tricky because it's not 100. It's, let me think about it for a second. Here's a meter. So it's 100 centimeters, 100 centimeters. So there's a square meter. So that's 10,000. Yeah, it's squared, 100 squared. So it's 10,000. And then that cancels. So then we'd have it. So it's 10,000 times 0.2. It's 2,000, but I'm just going to be safe. And 2,000 for the win. That is D. Interesting. And finally, number 10. A bottling company sells bottles of water, random sample of 50 bottles. Found that the bottles contain on average 0.96. Okay, 0.96 with a margin of error of 0.08. So I always, whenever I see margin of error, I'm always like, it could be 0.08 above, which is 1.04. It could be 0.08 below, which is 0.88. Which 98%, which of the following is a reasonable claim to make based on the sample? Company always fill, no, that's ridiculous. The company usually fills its water bottles between this and this. I would say, I want that 0.88. Yeah, I'm going with this one. Always is, I don't like that. No, it's not always. It is possible that the company usually fills, what? Usually fills water bottles with 1 or more liters of water. Oh, this is weird. This is different. See, I don't know what the word usually means. You know, it's a little weird. Like, I would say, does usually mean more than 50%? Yeah, I mean, B is, I think, our best answer, but this is not really the right type of language that they should be using. But I would say B. I wish they said 0.88 to that, and then always is too strong, right? Because it's just not like, you know, it's a 98% confidence level. So, all right, let's see what we got here. Ooh, that last one. Dang. What did they say? Oh, the company usually fills its water bottles. So it's possible the company usually fills its bottles with 1 or more liters. I mean, I guess it's ridiculous. It is possible the company usually fills its water bottles with 1 or more liters of water, since the confidence interval includes, I don't know. It's just strange, I suppose. I mean, I'll take the L. I'll take the loss. I did my best. Like I said, this is just not normally what's given. Usually it's like they go the full margin of error, the 0.88 to the 1.04. Obviously, this one, you can't have that always word in there. I don't know. It's just strange. So yeah, that is a strange one. Sorry about that, but 9 to 10, it is what it is. All right. Well, thank you guys so much for joining. If you did like this video, please click that like button. And if you want to see more videos from the Scalar Learning channel, make sure to click subscribe. And last but not least, if you do want to check out our SAT math video course, the link is in the description below. Check it out. Black Friday sale going down from Wednesday to Friday. 50% off. What more can I say? Thank you guys so much, and I will see you in the next video. Take it easy.